Okay, so homework 3, deadline 7th of November, 11:59 p.m. You sent me all your files to my email, and please notice that I added this. Plagiarism is strictly prohibited, guys. So, and you will understand why. I don't want people just copying my code and just pasting it on their files. Moreover, I don't want students sharing the same code and the same examples. This is your own homework, guys. Okay? You may work with your colleagues, you may exchange ideas, but definitely if you are submitting the same work, it means there's something wrong. And you will see there are many of mines, many of questions where possibly students can go different ways and have to go different ways. Okay? So first of all, for example, I'll start with question 1. It's about interpolative decomposition. The whole homework is on 40 points. First question is on 6 points. So I'm giving a 3x4 matrix, which is defined this way, and I'm asking you to find the adequate matrices Y, B, and Z such that A writes as YBZ. Okay, of course, we need the B here to be an invertible submatrix of A with the largest possible determinant. And possibly all entries in Y and Z to be in absolute value less than 1. Okay, so that's the YBZ factorization. And on the same matrix Y, I need a CMR factorization, where M is a mixing matrix. So possibly there are many different solutions here. Okay? So if I see a pattern like 5 to 6 or 10 people submitting the same answers on both questions, there is something wrong. Okay? Means someone naively accepted to work for them and just give them his work. And this is totally wrong. This is not the way you should be behaving in an academic environment, and more than this, in professional environment. You shouldn't leave any possibility to take you as his or her own free ride and free ride your work and your effort. Okay? And system-based, because if you choose to do this right now, you will suffer for decades. Question 2, splitting a system of equations. Now, we work with an example like this during the lecture. I'm giving you a matrix A. I'll come back on classes. I'm giving you a matrix 3x3 with a vector B, which is 3, 3, 3. Okay? And we would like to split this matrix into matrices S and T, such that A is equal to S minus T. Okay? We would like a convenient way to split it and solve it. Okay? Now, you see again, it depends on your choice. And I'd like you to show how to perform manually a first iteration based on your chosen matrices S and T. But I'm giving you just the initial vector x0, which is 1, 1, 1. Yes, Abdulaziz.
Doctor, regarding to the first question, actually I was solving, but in the Z update, there's something that is not less than the magnitude is not less than 1. So what can I do?
So possibly I was okay. Thank you, Abdulaziz, for notes. I think you already started homework, right?
Yes.
So possibly, if not possible, I mean, with the least absolute value. Okay. If you cannot find it, with possibly, as I said, possibly with all entries in absolute value less than 1. Okay. Right? You got it?
But دكتور يعني في كولوم في الزي ابديت ما كان الانتري حقه اقل من 1، كان في 2.
Okay, I get your point. Okay, So if you're satisfied with your answer, move on. Abdulaziz, don't waste time on that. If
Yes,
you're not
yes,
able to get it, okay,
it's
let's move on.
it's giving me the A actually, but I mean for the entries, because you say that all entries in A and Z and one in absolute value less than 1. But I have
This is yes, Abdulaziz, I got your point. This is a generic question. And possibly, if you can, as I said when I was reading, possibly with all entries in absolute value less than 1, you may not be able to find it. That's acceptable. Okay? Okay. So I was still in question 2. Can I move on, Abdulaziz?
Yes, sorry, Dr. Robert.
Okay, no problem. You're welcome. My pleasure. So I've not finished. So be careful, guys. I'm not finished with question 2. It continues in C, and here the guys who are still taking the time to learn Python, I would like you to use a Python implementation to show that your chosen matrices S and T help converging towards the exact solution in a reasonable number of iterations. Okay? And of course, you have no arguments if you are just taking my code and just fixing it and taking the same example one of your colleagues sent you and submitting this. It's not acceptable, guys. Okay? I won't be lenient anymore. If you do this, you get a 0 on the whole question. Now, question 3, as promised, I told you you need to learn Python more seriously. Now, here, the first question, what is the goal of the Lanczos iteration? It's on 7 points. What is the difference with the Arnoldi iteration? Question B, I'd like you to work on the Arnoldi iteration code I uploaded, modify it to obtain the Lanczos iteration Python code. Okay? And you need to comment your code within your own words, add your name, ID, attach it with your submission, and show that your code runs perfectly on your own chosen 5x5 adequate matrix. You'll understand later what do I mean by adequate matrix, because it has to fit some conditions for the Lanczos iteration. Hopefully it's clear for everyone. Okay? Now, question 4, pseudo-inverse A+. I'm giving you a 2x3 matrix, and I'm asking you to find the pseudo-inverse A+ for this matrix. And for BT, which is 3, 3, I would like you to find the solution x plus that is equal to A plus times B, and show that it's the least square solution to AX equals B. Okay? There is some condition to satisfy to say that this is the least square solution. Okay? Because there could be many solutions. Now, we'd like you to show how the singular variable decomposition, SVD, of A plus helps solving the SVD of A. Go back to the lecture slides, to the lecturing material, you'll get the answer. Now, question 5, Gram-Schmidt. We'd like you to consider this matrix, which is a small matrix 2x2, and perform manually the Gram-Schmidt factorization, which is A equals to QR. Okay? And verify that your solution satisfies the mathematical conditions ATA equals RTR and A inverse equals to R minus 1. Okay? Yes, Abdulaziz. Don't tell me that you already solved this question.
Actually, yes, but regarding to the second,
Mashallah Ali, go ahead.
regarding to the second situation that A inverse equal to R inverse Q, I worked on it, but it doesn't seem that it's equal. It's giving me another matrix.
So dig on it, Abdulaziz.
The first condition that says ATA equal to RTR, it's satisfied, but the second one is not.
So maybe there's something missing in your solution. Okay, because mathematically it should work. Huh? Okay. There is a condition that Q or R should satisfy, so you get A inverse equals R minus 1. Are you okay with this? Okay. Right. Okay. So let's move on. It's easy to find, yeah, Abdulaziz. Just a hint. It's easy to find. Right. And now changes in A inverse for the same matrix, which is here. Which was exactly given also in question 5. We'd like to find the inverse of M, which is equal to A minus UTV, where you have U equals 1, 1, and V equals 1, 1. So basically here we have a rank 1 modification of perturbation in A. Then it's the same question. We'd like to find the inverse of M, which is A minus U here capital times V. Just to notice the fact that U and V here, this should have been capital. U and V are matrices, okay? And this is a modification which is not rank 1. Of course, if it's not rank 1, it should be rank 2, okay? So basically you are by the end, okay? Now, question 7, which is more practical as promised. Yeah, Abdulaziz, since it looks that you were in a hurry to start solving, and be careful. When I uploaded the first version, just 30 minutes after I updated it, there was a mistake here. There was a 4 before the EC here in the numerator. It should be in the denominator. Okay. You already solved it. Seems that you already solved it. Okay. Right. So let me read the question. The Kalman filter here example details. You have a table that details respectively the traveling times in second measured between 2 points A and B. We don't care about what is A and B here, okay? But in the project, I'll give you what is A and B. I'll give you the geocodes, the longitudes and latitudes for A and B. Which reaches another subject I will talk about. But let me move on. With constant measurement error, EM, which is equal to 5 seconds, initial estimation of 309 x0, which is 309 seconds, and initial estimation error of 30 seconds. Okay? Now, here is the table. So you have different rows, the BTs, the measurements. We have 10 measurements. We have the, what else? We have the error of measurement, which is constant. We have the 2 filled previously initialized estimation errors, the ES. And of course, you need to fill in now the remaining entries, XTs, the EST plus 1, and of course the Kalman gain K. Okay. In the first question, how do you need to fill it? You follow the Kalman filter updating scheme with K is equal to ES divided by ES plus EN. With R, like the reliability coefficient, which is equal to 1. And you fill the table and explain toward which value your estimation converge. Now, question B, use the same or different, the same procedure, but still a Kalman filter updating scheme, but with a different K, which is ES divided by 4 ES plus EN. Okay? And a reliability, which is now of 0.95 to complete the table. And also conclude towards which value does your estimation converge. Of course, we are talking about the estimation of the traveling time, or the travel time between the 2 points A and K. Now, last question, we would like to discuss which updating scheme converges, first of all, faster, and which one is more suitable or more reasonable to follow. Okay? So that's it. Do you have any question, guys, for the on the homework? It should take you a couple of hours to complete it all. I would say maybe probably net 5 to 6 net working hours. Okay, but if you subdivide it on many days, it may take more. Okay. Any question, guys, before I move on? Okay.